you should not have any element in code of it which is not associated with any element in data. That is the function.
Okay, before we start, let us discuss what we have seen so far, the concept in the last lecture. What did we cover in the last lecture is about how to create instance of the WCF service. So there are three ways of creating the instances of the WCF service. Can you name them?
So we have to assume alpha and beta, f of alpha.
Correct, per call. So every time a request comes, a new instance will be created. Per session means within by the same proxy object. If multiple calls are received by the service, a single instance will solve all the requests. And finally, we have the singleton, in which case, irrespective of the number of client, same service will solve all the requests. Okay.
And many of you have also given the answer of that question.
So fine.
Let's continue today's lecture. So in today's lecture,
in addition to that, we have also execution of the service can be done by the multiple thread, and that is we call as the concurrency part. Okay, concurrency.
What is your understanding?
So how the same instance, same WCF service instance can concurrently execute multiple client requests. So it could be done by using multiple threads. So by default, there are 1,000 threads. So thread pool is available from which a thread should be assigned to the particular service instance. So how many, whether we want the concurrent execution should be allowed or not. So for that in WCF, there is a attribute called concurrency mode. Okay, so using this concurrency mode attribute, you can decide whether to allow this request to be served by multiple threads or not. So it supports three concurrency mode. One is single, another is multiple, and third one is re-entrant. So when we are using single concurrency mode, that means to that service instance object, only one thread can be assigned. And if we use the concurrency mode to be the multiple, that means for the same service instance, multiple thread can be assigned. So basically, if we are assigning more threads, more concurrent execution of the service request, and we get the better throughput. Okay, so ultimately it will lead to the better throughput if we are using the concurrent execution of the client request. And there is one more called re-entrant. We'll see that why we are using re-entrant. Okay, basically it is used when we are using the callback function. So it's a special type of concurrency mode required only for re-entrant call, callback call. Otherwise, you can use either single or multiple concurrency mode.
What you are saying about zero?
Is it clear, this concurrency mode? Everyone, I think the name itself suggests that single means only single thread is assigned to each service instance. Is it clear the difference between instance and concurrency?
Okay.
Because instance context mode and concurrency mode, these are two different things. They are not the same. Okay, so let's begin with the discussion, and we can set this thing both together, and depending upon the different combination, you will get the different behavior of your WCF service.
I have to look at the question because the next argument we will use to prove that it is onto or not, it depends on this n. Okay. So based on this assumption, we will prove
Okay, is the slide visible?
is onto or it is not onto. Uh,
Okay, fine. Thank you. So here it is described that there are three types of concurrency mode. Single means each service instance processes one message at a time, and this is the default concurrency mode. And that's why we have not discussed so far, because
okay.
by default,
So let I look at the
one thread will be assigned to one service instance.
the zero is part of this codomain.
Multiple means for the same service instance, multiple messages can be processed concurrently.
That F is not one to one.
And if you are allowing multiple threads to be assigned to the single service instance, there is a possibility of
So
synchronization issues.
all right.
All of you are familiar with the synchronization issues, and why do we require those? There are some well-known solution for that also.
Such that f of x is equal to y, right? Because we
What are the different solutions for solving the synchronization issues?
So every element in the n must have
Correct, semaphore.
corresponding mapping with some element.
There are two function weight and
So it is an onto function. It is an onto function. So this function is one-to-one function. It's not one-to-one, but it is onto function.
any other synchronization solution
Take
other
this,
than
next
semaphore?
example. Uh, Check whether the function is one-to-one or onto.
Correct, monitor. There is also message passing. Using message passing also, you can solve this synchronization issue. But widely used are the semaphore. Then you have the mutex lock, unlock kind of thing, binary semaphore. And you can have this monitor also. And in Java, have you used any such solution in Java language?
So these are the domain of the function. And the codomain is also z cross z. Right?
For Java language, do you know the solution?
Is f of a comma b is equal to where a plus b comma a minus b. Okay. So if I take
Correct. It is synchronized block. Okay. So just prepend the synchronize keyword against the method name or even to the block, then that entire code snippet will become, it will be locked. Okay, so at a time only one thread can execute it. It will act as a critical region.
So tell me what you think.
Right. And there is a facility of semaphores and monitor too. In C#, do you know the solution?
You can also follow the normal approach.
C# language?
You can put some dummy values and try to identify the nature of the function.
Yes, this await is for this asynchronous communication. Normally, await it is not for solving the synchronization problem.
Two values.
Await is normally used to when we are using the asynchronous call, and sometime you need to wait for the result to
If yes, then
come
it is
before proceeding to the next statement. Then await should be used. So in C# language, there is a locks are available, mutex lock, and
that function.
there are also monitor is also available in the C# language. So if you are interested, you can just explore the how to solve the synchronization issues in the C# language. Fine. So here, if you are using multiple concurrency mode, in that case, we have to deal with the synchronization issues ourselves. Okay, now it is the programmer's responsibility to handle this thing, because now multiple threads are accessing the said object, said properties, and there is a possibility of race condition. To avoid that, we need to use the this type of solutions.
F5.
Okay, if you are using this concurrency mode to be the re-entrant, then the service instance can process the messages one at a time, but it will also accept the re-entrant call.
We want to get 5 over here. Then we can't
Okay,
get
fine.
we can't get it, right?
So suppose we take a different combination. Suppose we are going with per call instancing mode along with the single concurrency mode, what will happen? So here is the
But anyways,
diagram. You can see that every client will have create the proxy object.
obviously you have to
Okay,
give a
and through
formal
that we are issuing a
give some blessing.
request.
Let's see what.
Now on the server side, suppose it is per call. So what happens for every request, a new service instance would be created.
So if you remember, we
So
assumed that
here
for some
you can
alpha
see
and
that there
beta,
are
f of alpha is equal
two
to zero,
clients. For each client, there are two requests,
prove that alpha is equal
and
to
for every request, new service instance is created.
so let's assume that f of AB is
And
equal
here
to
single concurrency mode means
f of A
only one thread will serve the request.
C comma B. Okay.
So this T1, T2, T3, T4 are the threads. Okay, those are assigned to each service instance.
C plus D and C
So there are
minus D.
four service instance, and currently they are processing the client request,
Get a
and
conclusion that
individual threads are assigned to them.
is equal to
So this is the simple one of the combination. Is this diagram clear?
the function is 1 to 1.
Understood?
So this should be the formal way of
This combination per call with single concurrency mode, single thread. Single means single thread will be assigned.
you have to prove it in a normal way. You cannot prove it using any argument.
But here you will see that per call means every time a request comes, a new service instance is created on the server side.
What about on
On the host, service host will create new instance,
what about on to
and a new instance will be assigned a new thread,
codomain? There is at least one
because every time at least one thread is required. Okay, as you know, if the program is executing, the main thread will execute the code.
for all xy belongs to z cross z.
Okay, let's take another combination per session,
In z cross z,
instancing mode, and single concurrency.
b is equal to x comma
Now see that here it is per session. So if the
x comma
from the same client with the same proxy object we are getting two requests,
is equal to x.
so only single instance will serve both the request. So there are two clients, so two instance will be created, because for each client there is a another proxy object, and for each client for each proxy object it creates new service instance. Okay, but for multiple requests from the same proxy object, the service instance remains same. Okay, now you will see that it is single. Single means at a time it can handle only one request. So at a time it can assign only one thread. So why it happens? Because internally what happens when it is assigning one thread, and it will lock the service instance. Okay, basically internally locks are there. It will lock the service instance, and if the second thread tries to access the service object, it will be blocked. All of you know, if the locks are there, then another thread cannot access it. So it acts as a SAD resource. Okay, and it acts as a critical region code. So even though there are two threads T1 and T2, for each request at a time only one will be served, because the concurrency mode is set to single.
So can anyone tell me why A and B does not always belong to Z?
Is it clear in this diagram? Per session, single concurrency mode.
Yes.
See that in T1 is currently in execution, but T2 cannot start because T1 has blocked the service instance, and T2 is blocked. Thread T2 is blocked. Similarly, for the another client, another proxy object, T3 has started. That is the first request from that client, but the second request is blocked.
With the domain and codomain of the function.
So T3 is in execution, T4 is blocked. If T3 finishes, T4 will begin execution. It can access the service instance object.
For 1 to 1.
Okay.
For 1 to 1, you have to assume
Yeah.
that for some alpha and beta, f of alpha
This is also single instancing mode with the single concurrency, because it is a single instancing, that is a singleton, irrespective of number of clients and proxy object. There is one and only one service instance created on the host side. Okay. But now the behavior, you can see that from one client, one proxy object, it can assign the thread, but the subsequent thread from the same client will be denied, or it will be blocked rather. Okay. So for the client 1, there is a thread T1. First request is assigned thread T1. Then second request is blocked. Okay. So the second thread cannot begin because the thread 1 has locked the service instance, and because there is only one instance, T2 cannot start. It can, once T1 finishes, it will release lock. It can unlock the service instance, and now T2 can begin. Meanwhile, T1 is in execution. There is a request from another client. So another thread would be assigned T3. But once again, this entire service object is locked. Neither T2 nor T3 can begin. They will be blocked. So for T4, another request from the second client. So likewise, you can see that as many request comes from as many number of clients, all of them will be blocked and they cannot continue because at least one thread is in execution, the entire service instance is locked. Is it fine?
This is the assumption that function is onto.
This combination.
But if we assume that function is onto, then I end up.
So on the service side, we can use this concurrency mode by changing the service behavior. Like we have changed the service behavior by using instance context mode. So we can also change the concurrency mode. So once these concepts are clear, then we can move on to the one of the demo application. But before we move on to the demo application, these concepts are clear so that we can know what should be the expected output or the working of our application. Okay, fine. So there are no doubts. We move on to the next combination.
So this is one function.
Yeah, so this is the comparison of per call instancing mode along with single or re-entrant concurrency, a single or re-entrant concurrency mode, per call instancing mode. So I think
if I associate one with C, two with
first let us discuss the left hand side part of the diagram. Okay.
What we will discuss.
Okay, just a minute.
Is that from A to B. Associate 3. So I can associate 3 with A, B, and C. Okay. So total, how many possible functions are there? That is the question. Okay. So if set A has m elements, if set A has m elements,
I hope that
in this case
my screen is visible.
And set B has n elements. This is
Okay,
m,
so
and this is n.
so first we'll discuss this left part of this
It
diagram.
happens that the total number of functions possible from A to B, total number of functions possible from A to B is n raised to m. is n raised to n. Okay. So in this case, suppose you have m is equal to 3 and n is equal to 2. So the total number of functions will be n raised to m, that is 2 raised to 3 is equal to 8. Okay. So if you want to verify this answer, you can do it. Okay. Create a table from A to B. Okay. Associate 3 with 1, 3 with A, 4 with B. Okay. And 5 with B. Likewise, you can do this, right? You have 3, 4, 5, and then do the association. One is A, B, A, then B, B, A. Likewise, you can go and you will find out that
Yeah.
it will be.
So if you have doubt in between, just unmute yourself and ask the question, because I cannot see your question in the chat box. Right. So you can see that in if you are using per call instancing mode and single concurrency mode. So what will happen? For every call, there is only one thread. Okay. And for every request, there is another service instance. So there are two requests, so there are two service instance will be created. First one this, and for second request, second service instance will be created, and for each one it is single. That means a single thread will access the or execute the code for each service instance. Okay, now this is fine. But now as we know, in the callback function, what will happen? The service can also call back the client. Okay, it can also call back the client. So that is also fine as far as the service is calling back to the client, and callback function will be executed on the client side. So that is also fine. But now if as far as this callback function is one way, it is fine. It will not create an issue. But if it is two way, that means some reply is sent back to the service. Okay. So on the same callback channel, it might be the reply will be coming back to the service. But now at this time, what is happened? This thread T1 has already locked the service. Okay, it has acquired the lock on the service. So now another thread is trying, or this reply is trying to access this service object, and that would be denied. Okay, that would be denied. Okay, that is denied. Are you getting what is the problem if we use per call with the single instance concurrency mode? Because thread 1 has already locked this service object. If the request comes from client back to the service, that request is denied. Okay, it is denied. And that's why we need to resort to the re-entrant concurrency mode. In the re-entrant concurrency mode, WCF will automatically, it will release the lock if it is calling back. So right now, suppose thread 1 is executing. Okay, thread 1 is started. There is a request from client to service. Okay, so thread 1 will be created. A thread 1 will be assigned. It can execute it. But now if there is a callback, during the callback, it will release the lock. Okay. And that's why if there is a reply from client to back to the service, it is allowed. Okay, it is allowed. So that's why if you are using callback, then we can use re-entrant. Otherwise, there is no need of re-entrant. And second case is if the callback is one way, in that case also, there is no need of re-entrant concurrency mode.
Put the value, it is 60. Okay, it is 60.
Is it clear?
0.5
Any doubt so far in this, the difference between single and re-entrant?
number of on-to functions.
Both are similar, but the behavior will only change. Behavior will only change if we are using callback function. And again, re-entrant mode is required only if we are using callback function, which is request reply kind of thing.
Proof of all these formulas is not in our.
Otherwise, the single is suffice. Okay, single mode is suffice. But again, if we want the multiple threads to execute, we need to resort to uh, multiple concurrency mode.
Think about all cases.
Okay.
The formula is sigma r is equal to 1 to n minus 1 raised to n minus.
There is one more like per session with re-entrant concurrency mode. So what happens
R raised to n.
for the multiple requests coming from the same proxy object? Single.
So this kind of examples, counting number of functions, one to one and one to functions.
For the multiple requests from the same proxy object, single instance will serve all those requests. Okay. So this is the first request. This is the second request, and it is re-entrant. Okay.
Given in the slides. So we are not looking at the proof.
So this is per session. So multiple requests are allowed. Okay, they are not blocked. So thread 1 will be assigned for the first request. Thread 2 will be assigned for the second request. But now the problem may arise because now for this callback, for this thread 1, it might release the lock. Okay, it might release the lock. But for the second thread, when it is accessing, it will lock this service instance. It may lock the service instance. And if the callback is again getting the reply back to the service object, it will be denied because currently T2 has locked the service instance. So again, this combination is important, whether it is per session or per call. Okay, if it is per call, there is no issue, but if it is per session, it will create a problem because the callback or the reply from the callback from the client will be denied, or it cannot access the service object because it has been already locked by the another thread. So
Count the number of subjective or on-to functions.
okay.
Count the number of on-to functions from A to B where A is equal to 4, that is M is equal to 4, N is equal to 2.
Next one is single instancing mode, that is the singleton and re-entrant.
Formula, try to.
Now the behavior is different in the singleton. What happens? It is singleton, so that's why there is a single service. Okay, it is single service, irrespective of the number of client requests. Suppose the client 1, this is client 1, this is client 2. I will call this client 2. So client 1 first issues the request that will be allowed. It will be allocated the thread 1. Okay, it will be allowed thread 1. Now there is a second request from the same client. Now here for singleton it is denying. Okay, it is not releasing the lock because there is a single service. So the lock has been, this entire service object is locked by T1. Okay, it has been locked by T1. So this T2 is not allowed. Then if there is a callback reply, that is also not allowed. But this will allow the another request from another client. So here it is allowing. So the behavior is different. That means for one client, it is allowing only one thread at a time. Okay, what we can conclude that for one client, it can allow only one thread to execute at a time. For the second client, this thread is allowed, but T4 is blocked. Okay, T4 is blocked. or if there is another request, that will also be blocked. Even for this client, there is another that will be blocked. So as far as only one thread is in execution, all the remaining threads are not allowed. So this is the behavior when we are using the combination singleton along with the reentrant concurrency mode.
So let's say if this A is
Is it clear?
4, 5, A is equal to, and B is A B. Okay. So N is equal to. So now, if I want to map T, how many options I have? I have two options, right? Either T will map to A or T will map to B.
Okay, fine.
Okay.
So
If I want to map 4, then which option
so
will
let us
be?
see the application.
Again, the same option. A and B.
Just
Because I am talking about normal functions. When I
okay.
am talking about normal
Just a
functions.
minute. It is
Okay. So again, it is 2. If I want to map 5, then how many options I have? Again, I have two options, A and B. So in that way, it is 2 raised to 3. So if you see, it is n raised to n. Okay? That was the example, right? Consider second case, where you have, so let's say, now I'm talking about one-to-one function. I'm talking about one-to-one function. So A is 1 to 3, B is ABC. Okay. Now in one-to-one function, as you know, if A is associated with 1, then A cannot be associated with any other element, right? So for associating 1, I have how many options?
okay.
3 options,
So
right? I have 3 options.
here,
I have 3 options.
what you can see that when
Now,
we are using this combination,
I have how many options? Now I have only 2 options, either B or C, because I cannot repeat A. Cannot repeat A, so I have 2 options. So it will be 3 into 2. And either I have, let's say I have associated 2 with C. So for now, 3. How many options I have? I have only one option, right? So in that way it is 3 into 2 into 1, right? So this is kind of formula.
so here when we are using single instancing mode, means there is only one and only one instance. Okay, irrespective of number of clients and proxy object. So for this client, there is one proxy object. I call it as a client one. I call it as a client two. For this proxy object, it can issue multiple requests. Okay. So if this is the first request, this will be allowed. Okay. Now, if there is further request from the same client, then those will be denied. Okay. Those will be denied. Even the callback reply. Okay. There is a callback from a service to client and there is a reply from client to service. So this will be denied. So here it will be locked per client. Okay. The service will be locked per client. But in case if the second client issues the request, then that thread would be allowed. So here you can see that T1 is allowed, T3 will also be allowed. But another request from the second client that will be blocked. Okay. So that will be blocked. So per client, only one thread can execute. If there is one more request, that will also be denied or it will be blocked rather. It cannot get the lock. So that is the behavior when we are using this combination, single and reentrant. So in practice, not all these combinations are used. This is for understanding. In case if you are using this combination, then what is the behavior? But in practice, normally either you use single with multiple or per call, sorry, per call with multiple or per session with multiple. And if you are using duplex communication, then you are going for reentrant. Otherwise, normally we don't use the reentrant.
Let's say I have 3 pigeons, P1, P2, and P3. Okay. Pigeons, P1, P2.
Is it
And
clear
I
now?
have
I
some
think.
pigeon holes, right? I have some pigeon
Okay.
holes where you can accommodate a pigeon, right? So suppose I have two pigeon
So
holes.
let's begin with the application.
So if it happens that the number of pigeon holes are less than the number of pigeons, in that case, in this case, the number of pigeon holes are 2. Okay. And 2 is less than 3. So if this is the case, then what will happen? That P1 will be mapped to B1. Let's say P2 will be mapped to B2. Now for P3, there is no option, but you have to either map it to B1 and B2. So in both of these cases, either B1 or B2 will contain two pigeons. Okay, will contain two pigeons. So this is the overall philosophy behind this pigeonhole principle. And now we will look at it in formal way and see what kind of problems can be solved. Okay. So the pigeonhole principle states that if n items are put into m containers with n greater than m, so again you have items n1, n2, n3 up to n, and you have
Okay.
uh,
So
n containers.
once again, we will create a service host and the client to understand this concurrency mode and their combination along with the instancing mode. We create a new project.
M is less than n or n is greater than m.
Okay, and let us see the
Contain more than one
interface. Interface contains one contract, one operation called hello, and it has been explicitly defined as one way. Okay, so that it will not create any issue with the single concurrency mode. Otherwise, it may create, if there is a duplex communication, we might need to use the re-entrant. So that's why this will work for duplex communication also, because the communication is one way. The client is not sending the reply back to the service in case if there is a callback. So hello method will be invoked and the client will send the client name to the service, and service may just display it that out of multiple client, thus we can identify that we are receiving this request from this particular client. Is this clear? Why we are using this hello with the argument? Because in the example, we are going to issue the request from multiple client. So this client name will distinguish the output from one client to another. So this is a simple interface, one operation, and there is a implementation. Now look at this implementation.
So I hope that you are getting the overall idea.
So the one of the combination instance context mode equal to per call and concurrency mode to be the single.
In general, okay, now we are talking about.
So this is the same as the previous example, but now we are displaying the counter value. But now we are using the concurrency mode. So now there is little bit of complexity added because multiple threads might be possible. But this case right now, there is single thread. So it is easy to understand. I hope that this combination is easy to understand. Per call, single.
I is unique of PIR such that f of P1 equal to f of P2.
Because for the client, if there is a request, a new service instance will be created. If there is another request, another service instance will be created. Okay, for the same client. And this is a thread 1. It will be executed by another thread. Likewise.
Then at least how many people should be born in the same month? So we have to determine this I. We have to determine this I.
Now you'll see the implementation. What we are doing, we are incrementing the counter and displaying the client name, the value of the counter. Now you'll see that we are also displaying the thread number. So we are using the thread class thread.currentThread.manage thread ID. So thread ID will be displayed and the time also. So and now we are adding this delay, 5-second delay. Okay, we are adding the 5-second delay. Okay, so here you can see that
there's no specific problems.
we are displaying the client name. Then
And if you
I
have this
think
kind of scenario, which is given in the slides,
we are displaying the counter value.
pigeon hole principle,
Then we are displaying the
output something.
thread ID. Okay,
So whenever you
and
are
finally the current
of
date
this
and time. Okay,
and you want to compute some fact, then this pigeon hole principle can be useful. Okay.
so is it clear?
Let's take the example. So if 50 bicycle,
Any doubt in this implementation of the hello? Because when we are designing the client at that time, this logic should be remembered. Okay, what is the expected output? And it is very simple.
I have seven colors,
Basically, here
C1, C2, C3.
increment the counter value and display it over here. Okay, display the counter value.
How many bicycles? Same
And
color.
this is important. We are
The pigeonhole principle
explicitly adding the 5-second
we
delay.
can say that these are the 50 pigeons are there and seven holes are there. Right? Seven holes and
Okay,
50
this is the,
pigeons.
and we have also said these two
Is
things.
equal to seven.
Okay,
Okay.
instancing mode per call and concurrency mode single.
You can
So this
consider
is our
eight
service. Then we host it.
eight bicycles.
Now we'll see that right now we are using the form based host,
So you can
and it
also
might create some issue. We'll see that why it will create the issue.
normally, but normally this
The service is running. Now the host is running the instance, service instance. Now let us go to the client design. Okay, this is our client.
we need to
So here the user will enter the client name. When the user clicks on the button, that name will be sent. Hello method will be invoked on the service side. And on the service side, we are logging this value. Okay, on the service side, we are logging the client name, the current date and time, the counter value, and the thread ID. Okay, four things we are logging.
require anything. Answer in the chat.
Okay. Now add the service reference.
Now
Now in
change
the
from
implementation, you can see that we are
let be and
invoking
equator
this
or
hello five
triangle
times.
whose sides are of length
We
1.
are invoking the hello five times.
So I have a triangle whose sides are equal to
Is it clear?
1.
If we click on the button,
So
if we click on the button,
triangle,
this hello method
all sides
will
are
be invoked five times because we are iterating it
in 5
five
lines are
times.
chosen in on.
Okay, so this you remember that
Okay,
hello method is invoked five times. And what should be the
5
output?
points.
What do you think? What should be the output?
Anything.
If we just click on this button and write down client name, say uh,
Then you have to
client one,
any 2 points. Take any 2 points.
what is the expected output?
Suppose I take these 2 points, P1 and P2,
On the service side, we are logging something.
should no more than be zero point 0.5. It should be either zero point 0.5 or less than zero point 0.5.
So
This time
what is expected on the service side? What will be logged on the console window?
pigeonhole principle. Okay.
What we are displaying? Counter.
Then we will go ahead
Sorry.
with the solution.
Basically, we are logging counter. Sorry, here it is.
See, the logic is you have pigeonhole principle somewhere, right? Now, 5 points are
Okay.
given, right? So one
Just
of
a
the
minute.
thing is already given. You have to feed 5 points. Okay. So there are pigeons and there are rows, right? So one of them is given, and the other thing you have to find. And then apply the principle. So let me draw the triangle in another way, if it makes more sense.
So basically what we are logging? Counter value.
We have we have 5 points, and we have how many triangles now? We have 4 triangles. So it becomes a standard pigeon hole principle now, right? So you have 5 points and 4 triangles. So whatever arrangement you do, triangle, one of the triangle will always
Counter,
contain
that is nothing but the value of 5.
minimum 2 points.
Then we are displaying
And if that is the
thread
case,
ID.
whichever triangle is having 2 or more points,
Then we are displaying the
distance
date and
between the
time.
points will be no more than 0.5. The distance between those points will no more be
What else we are displaying?
0.5.
We are adding the 5-second delay. Okay, we are adding the 5-second delay. Okay,
So first I am dividing
and this hello will be called 5 times. Okay, so this is you need to remember. And the mode, instancing mode is per call. Instancing mode is per call, and concurrency mode is single. Okay, so for every request, if there is a request from client, a new service instance will be created.
because according to the pigeonhole principle, if 5 points are chosen, then 2 of them is no more than
So now,
apart because they will
suppose we give the client name as first client and we get the output. Let's see this output. We'll see that because there is a single instance, single thread is there, so thread ID is same. And per call, that's why for every call there is a separate instance will be created, so the counter value is 1. Okay, the counter value is 1.
prepare for a championship match by playing
But now we'll see that
77 days.
it is there is a some delay. Okay, 5-second is delay. 5-second delay is introduced. Okay, 5-second delay is introduced because the same thread is going to execute. So first thread will finish, then it will execute the second instance, then same thread will execute the third instance, and so forth. So there is a 5-second delay. You can see over here there is a 5-second delay between each request. Okay, so this is expected because single thread is executing for every client. So it is per call. I think single thread is executing. If we change the mode from per call to per session, and if you allow the multiple threads to execute, we'll see the output directly. Okay, so here you'll see that there are some threading issues are there, and the reason that multiple threads are not created, you can see the thread ID is 8 in every output, because the we are creating Windows Form application, and in the Windows Form application, if you are using there is a one UI thread, okay, one UI thread, and if you try to access the another from if you are creating another thread, and from that you try to access one of the Windows Form control, it will not allow it. Okay, so that issue will discussed in the next lecture, but this I will discuss the solution. The solution, there are two solutions. Either you use the console based application instead of Windows Form based application, and then just a minute. Am I audible? I think, yeah, it looks like I am audible. Yeah. So the solutions are that you use the console based application, or there are you use the delegate function. So for GUI, there is a facility called delegate function. I think, have you studied delegate function? Uh, Delegate function in C Sharp? Yes, I am getting this response. Okay, so second solution, you use the delegate function over the different controls, form controls. Okay, meanwhile, there is okay. So for the first solution, what I am trying right now, I am using the console application to host my service, and then if we go for the thing, then we'll get the correct output. So let us see that. I think service is hosted now, client 2, and let me just zoom in. Yeah, we'll see that for the same client, we call the hello method 5 times. Okay, we call the hello method 5 times. So there are, for every method, there is a separate thread is created, but the counter value is incremented by 1. So 1, 2, 3, 4, 5. And this thread issue is multiple threads are created, which was not created because of Windows Form based host. And you will also see that these threads are concurrently executed by looking at the log, the time log. Okay, you can see the just say 20 up to the second level, hour, minute, and second. You can see that they are almost executed concurrently. Okay, so these threads are assigned to the service instance, and they are executed concurrently. So the which thread will finish first, we don't know, because it depends upon at runtime the load on the system. The thread switching can occur, and they can execute it concurrently. So this is per session multiple. Right now, this is one client. So multiple calls are there. For each call, there is a separate instance, and for each one, due to multiple threads are assigned. Okay, if we say for the same service instance, if we use another client, and you see that there is a client 3. The client 3 will execute hello function 5 times. Every time it will create a separate thread because it is multiple, and you can see the timings are almost same. Okay, they are running, they are started concurrently. Okay, so if you look at the exact timings, they are started concurrently. So this is the counter value incremented 1, 2, 3, 4, 5 because it is per session. So per session there is only one service instance. Okay, per session there is only one service instance, and that's why the counter value is 1, 2, 3, 4, 5. Okay, If it is per call, the counter value will remain same 1111 for every request, because if we are calling hello 5 times, the counter value will remains. It will be initialized for every new instance. Okay, but in per session there is only single instance is created on the service side. Okay, then we have okay, there is a second solution. So right now we are not discussing that part, but maybe yeah. Then we have we change the combination per call single, so that we have seen. I think the output is yeah, for per call single. What happens? For every request, a new instance will be created, but concurrency mode is single, so only one thread should be assigned. So you can see the single thread ID is 4. Same thread is assigned to each instance, and because there is only one thread at a time, it can execute only one instance. So you will see the timing difference, 5 second delay between the output of this. So it will look like they are executed sequentially. They are executed sequentially. So remember, per call single, even though it is per call, because we are assigning a single thread, same thread will execute the code, and that's why we get the 5 second delay. There is no concurrency. In fact, we do not get any concurrency. Okay, fine. I think we are running out of time. Again, we'll continue with this example demo application in the next lecture. We will revisit this application and once again see the remaining combination output.